So this is a question from organic named reactions. So first of all, Schwartz reaction is given. Schwartz reaction is used to prepare alkyl fluorides. So it is a halogen exchange reaction. If I am going to take Rx, that may be an alkyl fluoride or alkyl bromide or alkyl iodide, which is on reacting with AgF, fluorinating agents like SBF5 also you can take. This halogen is exchanged by fluorine, then you can get alkyl fluoride plus AzX. So the correct match for A is 4. So Schwartz reaction is used to prepare alkyl fluorides. Sandmeyer reaction. So if I am going to take the compound like benzene diazonium chloride, which is on reacting with the compound like CuCN, Cn minus will replace the N2Cl, then you can get the compound benzene which is connected to Cn, cyanobenzene. So cyanobenzene or chlorobenzene or bromobenzene we can prepare by this reaction. So here the correct match for the B is 3. And the next one, pouch feeding reaction. For example, if I am going to take one aryl halide like chlorobenzene, which is on reacting with sodium, and another one I am going to take a normal alkyl chloride like methyl chloride in the presence of sodium. So CH3 will attach to this benzene, then you can get benzene which is connected to CH3, methyl benzene or toluene we can prepare here. So the correct match for the C is ethyl benzene or alkyl benzene we can prepare here. Finkelstein reaction is used to prepare alkyl iodides. It is also halogen exchange reaction like Schwartz reaction. If I am going to take an Rx, that may be RCl or RBr, which is on reacting with NaI in the presence of acetone. Halogen exchange reaction takes place through SN2 mechanism. Then you can get alkyl iodides. So ethyl iodide we can prepare here. So the correct match for the D is 2. So D2 and here it is B3, C1. Option 3 is the correct answer for this question. So here the two statements are given. Fructose does not contain any aldehyde group but still reduces the Tollens reagent. So we know that fructose is a best example of reducing sugar. So what is meant by reducing sugar means the carbohydrate that can reduce both Tollens and Fehling reagents are called as reducing sugar. Fructose is the reducing sugar. So statement 1 is correct. Statement 2, in the presence of base, fructose undergoes rearrangement to give glucose. Yes. In the presence of alkaline medium, glucose, fructose, mannose. These three are in equilibrium. And the formation of glucose also makes that particular Tollens reagent to get the cellular measure. Statement 2 is also correct. Statement 1 is correct. Statement 2 is correct. So option 2 is the correct answer for this question. The major product of the following reaction is, here it is the propanaldehyde is given, which is on reacting with excess of formaldehyde in the presence of alkali. So if I am going to take the propanaldehyde, CH3 single bond CH2 C double bond OH propanaldehyde, which is on reacting with formaldehyde in the presence of base. So this is Aldol reaction and best example of crossed Aldol reaction. Here propanaldehyde is having the alpha hydrogens, which is on reacting with the formaldehyde in the presence of base to get a beta hydroxycarbonyl compound. So here the nucleophilic attack takes place on formaldehyde and proton abstraction takes place here. Thereby if one formaldehyde reacting with the propanaldehyde, you can get the compound CH3 single bond CH2OH, which is connected to CHO and here one hydrogen is there. If it is reacting with formaldehyde in the presence of base, you can get CH3 single bond C, CH2OH, and you can get CH2OH, CHO. That means one propanaldehyde reacting with the 2 moles of formaldehyde in the presence of base, you can get this particular di-beta hydroxy aldehyde. Here this compound is not having any type of alpha hydrogens. Still, if it is reacting with formaldehyde in the presence of OH minus, now it will undergo Cannizzaro reaction, because both the carbonyl compounds are not having alpha hydrogens. Both the aldehydes are not having alpha hydrogens. Then what happens is, the most reactive aldehyde, formaldehyde, which will undergo the oxidation HCOO minus formate plus, and this will undergo the reduction. So aldehydes and reduction, you can get its corresponding alcohol CH2OH, single bond CH2OH, and CHO has been changed to CH2OH. Formate can give a positive tolerance test. So here you have to get the major product of the following reaction. So it is not a major product, it is not a major product, it is a major product. Option 3 is the correct answer for this question. The correct stability order of the following species of the molecules is. So here the compound given, the species given is cyclopropanyl anion. Cyclopropanyl anion is a cyclic compound. It is a planar compound. Resonance is exhibited by this compound, but 4 and pi is equal to 4 electrons. N is equal to 1 whole number. Cyclic, planar, conjugated, and obeys the 4 and pi electrons. That's why it is anti-aromatic compound. Anti-aromatic compounds are highly unstable. But if I am going to take cyclopentadienyl anion, it is a cyclic compound, planar, conjugated, but 4n plus 2 is equal to 6 pi electrons. 2 plus 2 plus 2. Then 4n is equal to 4. N is equal to 1 whole number. So it is a aromatic compound. Aromatic compounds are highly stable. If I am going to take cyclooctatetraene, double bond, double bond, double bond, double bond, and this compound is a cyclic, but it is not a planar. It is the presence of hydrogens repulsions. It is not a planar. If it is not a planar, it is not an anti-aromatic compound or aromatic compound. This compound is a non-aromatic compound. Non-aromatic compound. So first of all, you have to give a priority for the stability aromatic, and then non-aromatic, and then anti-aromatic. So Q is more stable when compared to R, when compared to P. Q or P is there in option 1, which is the correct answer for the given question. So here the question is, propane molecule on chlorination under photochemical condition give the dichloro products X and Y. So you have to take the propane, which is on reacting with chlorine in the presence of sunlight. Then you can get 1, 2, 3, and here it is chlorine, N-propyl chloride and isopropyl chloride. And now among X and Y, X is optically active molecule. So in this one it is indicating with dichloro products. I am written only monochloro products. Just convert it into the dichloro products. So if I am going to write Cl here, 1, 1 dichloropropane, and if I am going to write Cl here, 1, 2 dichloropropane, and here it is an optically active. So here among X and Y, X is optically active molecule. Here it is X is optically active molecule. How many trichloro products considered only structural isomers will be obtained from X if it is further treated with the chlorine in the presence of photochemical conditions. For example, if I am going to take the dichlorooptically active compound 1, 2, 3, and here it will be Cl, and here it will be another Cl, which is on reacting with Cl2 in the presence of sunlight. This particular hydrogen is replaced by chlorine. This is one trichloro product plus, and here it is Cl, and here it is Cl. This is another trichlorinated product. 1, 2, 3 Cl. Here it is Cl. If this carbon hydrogen is replaced by chlorine, then you can get 3 trichlorinated products. Option 4 is the correct answer for this question. What amount of bromine will be required to convert 2 grams of phenol into 2,4,6-tribromophenol? So if I am going to take, this is the question from phenol concept. Phenol, which is on reacting with 3 bromine molecules, then you can get the compound benzene, which is connected to OH. Here you can get Br, ikkada kuda Br, with the elimination of 3 HBr molecules. In this reaction, every 1 mole of phenol reacting with 3 moles of bromine to give this particular compound, you have to find the amount of bromine will be required to convert 2 grams of phenol. So phenol, if I am going to take its molecular formula C6H5OH, if you are calculating its molecular weight, 94 grams. 94 grams of phenol will require 3 into 160 grams of bromine. Then 2 grams of phenol need how much amount of bromine? If I am going to do the cross multiplication, 3 into 160 into 2 by 94, then you can get the answer 10.22 grams. It is there on option 1, which is the correct answer for the given question. Statement 1, Lesson's test, the covalent organic molecules are transformed into the ionic compound. Yes. Lesson's test, the given organic compound is treated with sodium metal, then all the covalent bonds will be converted to ionic bonds to get the more reactive nature. Statement 1 is correct. If sodium fusion extract of an organic compound having nitrogen and sulfur, then the Persian blue color is obtained. It is wrong. If nitrogen is there, then you can get Fe4 FeCN6 thrice. If sulfur and nitrogen are there, then you can get FeSCN thrice, that is blood red color. So if both sulfur and nitrogen are there, you are going to get the blood red color. But here it is Persian blue color is given. Statement 2 is wrong. Statement 2 is wrong. Statement 1 is correct. Option 4 is the correct answer for the given question. Which of the following can react to the Hinsberg reagent? So Hinsberg reagent is called as benzene sulfuryl chloride is called as Hinsberg reagent, which is used to separate primary, secondary, tertiary amines. Hinsberg reagent can react with the primary and secondary amines, but Hinsberg reagent cannot react with the tertiary amines. Aniline is a primary amine which can react with the Hinsberg reagent. It is a N-gamma and dimethyl is not a primary or secondary amine, it is a tertiary amine, it cannot react with that one. Methylamine it can react, trimethylamine it cannot react, and diphenylamine that can react it in the secondary amine. ACE can react with the Hinsberg reagent. It is an option 4, which is correct answer for the given question.